Okay, so we want to look at a chi-square test for association. Minitab will call this test a test for association as opposed to as opposed to a test of homogeneity or independence. Okay, so I've got an example here on the left. At Jensen Land High School, the administration is considering possible changes in its advisory program. As part of their decision-making process, the administration surveyed their students, asking them whether they would prefer for the advisory classes to meet monthly, weekly, or not at all. The results of the survey are indicated in the following table, and I hope I don't need to read those results to you completely, but you do see that the numbers we surveyed around 90, 95, almost 100 students from each class, and you'll notice that the numbers are slightly different. We're wondering if the desire to meet monthly, weekly, or not at all is dependent upon which class, freshman, sophomore, junior, senior, students belong to. In other words, our null hypothesis would be that there is no relationship between the class a student is in and their opinion on how often the advisory period should meet. Their alternate hypothesis would be that there in fact is a relationship. So we want to do a test to determine whether it's reasonable to conclude that there's a relationship or not. When I go to Minitab to do the test, I can go to I'm going to go to Stat, Tables, and use the chi-square test for association. Now notice that's chi-square test for association is what Minitab calls a test, whether it's homogeneity or independence. When I go to do this test, we either have raw data, or in this case, I have the summary data in a two-way table. So I first need to put my data into the data table here at the bottom, okay? So the classes we have, freshman class, sophomore class, junior class, and the senior class, meeting monthly, weekly, and not at all. Okay, and we'll put our numbers 45, 50, 45, and 35. 2015, 2015, and then 30, 25, 25, and 40. So if I do a quick look, it looks to me like the seniors are more interested in meeting less frequently or not at all than are the other classes, but we're going to actually do that test to see if it's reasonable to conclude that based on our data. So again, Stat, Tables, chi-square test for association. We have summarized data. Now the columns containing the table are C4, C5, and C6. Okay. The labels for the rows, this is optional, but I put the data in here. The column with our row labels is C3. Okay. We can select which statistics. I don't think it's necessary to change this, but what do we want to show? We simply now click OK, and we'll see here is our chi-square table. Notice our observed values, 45, 20, and 30 for the freshmen. We sampled 95 freshmen. Sophomores, 50, 15, 25. These are the observed values. The expected values, assuming no relationship, are the decimals at the bottom, the 45.55, the 18.22, and so on. And those would be the expected values if, in fact, there is no relationship. When I come down here, notice we have our p-value. We're going to use the Pearson P-value. A chi-squared test statistic is 9.049 with a p-value of 0.171. That is greater than 0.10, greater than 0.05, greater than 0.01. So regardless of our level of significance, we would therefore fail to reject our null hypothesis, and we can't conclude. As much as it looks like the seniors tend more toward the not at all, this data is not sufficient to conclude that based on the sample that would bear out in the population. Okay, so there's chi-square test for association using Minitab.